In this lesson, we are going to find relation between roots of the quadratic equation and coefficients of the quadratic equation. Let's get started with quadratic equation in standard form. So, quadratic equation in standard form. Standard form is ax square plus bx plus c equal to 0. We know by quadratic formula, quadratic formula that x is equal to minus b plus minus b square minus 4ac square root divided by 2a. Means that these are two values of x which, if replaced by x in the equation, they will satisfy the given quadratic equation. Let's name one value as alpha and the other value as beta. Let us name one of the two values of x as alpha and other as beta. And to be more specific, if alpha is equal to minus b plus b square minus 4ac divided by 2a, and the negative value, the beta, is equal to minus b square minus 4ac square root divided by 2a. So that is clear because there were two values of x and we have named each one of them separately. One is positive sign and the other one is negative sign. Now if we want to find out alpha plus beta, now sum of roots which we will from now on we will denote as SR. So SR is equal to alpha plus beta. If we want to find out the sum, then that means alpha plus beta is equal to minus b plus b square minus 4ac square root divided by 2a plus minus b square minus 4ac square root divided by 2a. So because the denominator is same, so we will have the denominator 2a, and in the numerator we will have minus b plus b square minus 4ac square root minus b square minus 4ac square root. Now because b square minus 4ac has one time positive sign, one time negative sign, so that will cancel out, and minus b will be added. This will be minus 2b over 2a. This is equal to minus b over a. It means for any quadratic equation, the sum of roots is equal to minus b over a. So if alpha, beta were the roots of a given quadratic equation, then alpha plus beta is equal to minus b over a. Remember this formula because we are going to need it a lot while solving problems related to these equations. Also product of roots. Product of roots is equal to alpha times beta. This means that alpha times beta is equal to similarly minus b plus b square minus 4ac square root divided by 2a times minus b minus b square minus 4ac square root divided by 2a. That will be their product. But if you look carefully, the first part here minus b, first part is minus b, the second is b square minus 4ac square root, b square minus 4ac square root. So if we remember that formula, a minus b times a plus b equal to a square minus b square, we can certainly apply that formula to find out the product. This means that alpha beta will be equal to minus b square minus b square minus 4ac square root square by applying a minus b times a plus b formula divided by 2a times 2a will be 4a square. So this will be 4a square. Now alpha beta is equal to b square minus square root will be cancelled with the square and we are left with b square minus 4ac divided by 4a square, which in the next step can be written as b square minus b square plus 4ac divided by 4a square. So this minus b square and plus b square are cancelled out. Alpha times beta, and alpha beta is written as 4ac over 4a square, means alpha beta is equal to c over a. So this is number 2. This way we can find out sum of the roots and product of the roots without actual calculation of the roots, simply by using this formula in 1 for sum of roots and 2 for product of roots. Now let's take a look on the question. In the next question here, it says if alpha beta are roots of the equation ax square plus bx plus c equal to 0, find the values of alpha square plus beta square. So let's do question number 1. Question number 1. If alpha beta are roots of the equation ax square plus bx plus c equal to 0, then from the formula we have just learned, alpha plus beta is equal to minus b over a, and alpha beta is equal to c over a. And we want to find out the value for alpha square plus beta square. Interesting. Alpha square plus beta square can be written, if you remember the formulas for algebra correctly, alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. We just write in terms of alpha square plus beta square can be written in terms of the sum of roots and product of roots alpha beta. So anything can be converted into a different form where we have the sum of roots alpha plus beta in one place and alpha times beta in the other place. Now alpha plus beta is equal to minus b over a. So if we take square of this, minus 2 times c over a, this is what was required of us, that b square over a square minus 2c over a, and here we can take the LCM, that is a square, and this will be value b square minus 2ac. Similarly, if we want to write out another one, now we want to find out the value for alpha square over beta plus beta square over alpha. Again, the same trick. Whatever we get, we will write the product or whatever the expression is in terms of alpha plus beta and alpha into beta. So let's simplify this by taking LCM. Alpha beta, this will be alpha beta, and here it will become alpha cube plus beta cube. Now alpha cube plus beta cube can be written in terms of alpha plus beta and alpha into beta like this: 1 over alpha beta, this is this denominator, and alpha plus beta can be written as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So now you can see that there is not a single place where, oh, this is beta cube. So there is alpha cube plus beta cube is written in terms of alpha plus beta and alpha into beta. We can again substitute the values. 1 over alpha into beta is c over a time, and this would be minus b over a whole cube minus 3c over a into minus b over a, and this can be easily simplified. This will be a over c into b cube over a cube minus, time minus will become plus, and this will be plus 3bc over a square, and we can take LCM inside. This will become a over c into b cube plus 3abc over a cube, and we can cancel out the a which is outside. This will give us b cube plus 3abc over a square c. So there is third component to this, that now we are going to write alpha minus beta whole square. So for third part, alpha minus beta whole square, this also can be written in terms of alpha plus beta and alpha into beta like this: equal to alpha plus beta whole square minus 4 alpha beta. And again, for the same reason, we can write minus b over a, the value of alpha plus beta, sum of roots square, minus 4 c over a, and here we have b square over a square minus 4c over a, which will be written, if we take LCM, that could be written as b square minus 4ac over a square. And now we are going to take a look on the next question here. The next question says, if find the condition that 1 root of ax square plus bx plus c is square of the other. So if alpha is 1 root of the given equation, so example number 3, if alpha is 1 root of the equation ax square plus bx plus c equal to 0, then other root will be, what does this question say? The question says that the second root is double of the given root. So if the given root was alpha, then the other root must be double, mean 2 alpha will be 2 alpha. And just the way we have done previous question, alpha plus 2 alpha means sum of the roots 2 alpha is equal to minus b over a, and product of roots alpha time 2 alpha is equal to c over a. Now we will find value of alpha from equation 1 and we will substitute in equation 2, and that will give us the required condition. So this means this is 3 alpha. 3 alpha is equal to minus b over a, or alpha is equal to minus b over 3a. Let's call this as 1, and this means 2 alpha square is equal to c over a. Let's call this as 2. Now substituting value of alpha from 1 in 2, what we get is 2 times alpha square, mean minus b over 3a square is equal to c over a. This means 2b square divided by 9a square is equal to c over a, or in other words 2b square over 9a. 9a is equal to c, or in other words this can be written as 2b square is equal to 9ac, which is required condition. We'll see you in next lesson with more questions.